so what we thought we'd do is spend a little bit of time explaining some of the dynamics that we saw in the storage industry that we think actually map to the flash industry moving forward. So one of the phrases that you hear fairly consistently in the industry today is software-defined storage. And I thought it would be instructive just to put a definition up, because I've seen several people talk about different implementations, different incarnations of software-defined storage. But I think at the heart of it, I hope everyone will agree that really its fundamental premise is that you can take standard hardware and leverage that by developing software on top of it to differentiate. You put essentially the important storage and management functions, as it says in the definition, in intelligent software. Now this is relevant, I think, and we'll get to how we think this applies to the flash market in just a moment. But this is relevant because it's something that's existed for a very long time in our industry. We've seen this before. And the underpinnings of what made this possible date way, way, way back to a transformation that we think took place in the compute industry. So if you were able to hop into the Wayback Machine, strap on your seatbelt, and turn the dial back to the late 70s and 80s, and you looked at who the players were in this space, you would essentially see folks like those listed: Digital Equipment Corporation, National Cash Register, IBM. Now, what was unique about all of these individuals when they built their solutions is they built them from the ground up, and they did everything in-house, a vast majority of it in-house. Not quite everything, but they had ASICs. They had in-house software, operating systems, all of the infrastructure, and inclusive of enclosures. All of the pieces needed to stitch together a complete solution came out of these companies. But that's not the way that it ended. That's not the way the industry is today. And there's a series of reasons for that. What's happened over time is a series of ecosystem components have been created. And they've generated slowly. There's no doubt it's taken a while for us to get to this stage. But we think that there were three factors that actually enabled this. The first factor was the fact that people recognized that these large systems could be shrunk down into something that was more personal. And if that was able to be done, a large amount of volume could be enabled. So there was volume economics. The second factor that enabled this was they said, all right, if we're going to launch a large amount of volume, we actually should standardize some of the work. Let's spend some time thinking about how can we establish standards. And in the earliest days, some examples that we actually see today, PCI was created, the interconnect between multiple devices sitting in a PC. That evolved into PCIX and PCIe and is carried forward to create a series of different options for products to be put into PCs. There was a standard around form factor. ATX got created so that you could source motherboards with different configurations of products from different places. All of these standards wrapped together formulated this environment where you could get the ramp and volume of the products. Now lastly, the final piece that was laid on top of this is everyone wanted some way to differentiate. And they had to find that way. And we saw as the evolution of HP occurred and IBM and their presence and Dell and several others, there was quite a lot of work put into differentiating the multiple solutions. And that came in a vast array. But those were the three components that we saw: unit volume, standards, and then lastly, finding sources of differentiation. So it's really, it's fair to ask the question, all right, so what does all of this have to do with flash? And we think in the SSD marketplace, we have some very, very similar dynamics that are at play. If you were to wind the clock back on the SSD marketplace, you could see in the very early days there were some quite niche applications that were initially created where there was value in eliminating rotating media, and people were willing to pay a very high price for these solutions. And in fact, that was, back, even into the days of the 80s, there was work being done there and into the 90s. But as people realized they could take NAND flash and put it into applications to accelerate things in both the client space but also in the enterprise space, we started to see more of an uptick, the formation of many of the companies that are here today. And that growth just continues to go. And the enterprise space in particular, that's where we play, as I mentioned before. We don't see an end to this for a very, very long period of time. So that first pedestal on the stool that I talked about, growth, we think applies to SSD. So then the next piece becomes standards. Now, I think a ton of work has poured into this. For any of you that have been here for several years in a row, you can attest to the fact that there's been a ton of work put into NVM Express, the first of these standards shown on the left side of this graph. NVM Express, the actual organization now, is north of 50 member companies. But essentially what they did is they had the foresight to sit down and say, you know what, we think PCI attached SSDs are going to grow in volume. We see this opportunity out in time. How do we create standards so that we can enable more volume growth? But let's not just do it for NAND. Let's sit down and let's look at what are the trade-offs, what are the considerations for what comes after NAND? How do we enable a set of protocols that are favorable to things that are after NAND? Things like, pick your 3 or 4 letter acronym, PCM, ReRAM, SDMRAM, et cetera. But that work has generated a substantial amount of traction. And in fact, this is the first standard where they've actually set off to enable inbox drivers to be provided in the multitude of OSs out there, where that inbox driver actually showed up before drives did. So there's definitely a sign of willingness on behalf of the operating system vendors to absorb this technology. Now, I mentioned a couple of other standards back in the good old days of the PC industry, one of which was the ATX form factor, where they essentially specified for chassis vendors the chassis, the motherboard, the power supply, all of the pieces that come with it. The form factor working group in the SSD space actually did something very similar. They created essentially a specification that talked about the mechanicals, the connectors, the power that was delivered into this. And we're now at a point where we have a published spec and we have solutions being delivered by all of my colleagues that have been up here today, a good number of them. The final piece, and there's several more that I'll touch on, but the final piece on this slide, just to say a few words, is SNIA has actually recently started to work in a technical working group to create programming models that consider non-volatile memory. So one of the challenges that surfaces is you get this high-performance SSD that shows up on your doorstep, you plug it into a system, and the system doesn't necessarily take advantage of all of that performance. And something needs to be done to unleash that performance. And part of it is the software, part of it is the operating systems, part of it is the protocols. But they're looking at ways to set up programming models to accelerate that. But what are some of the standards that are missing here? You essentially have PCI Express. We mentioned that earlier. I talked about that with the PC industry. You also have T10 with SAS. There's a whole host of them. But the point is that several of these standards have been put in place. So the second leg of that stool, remember I'd mentioned robust growth, and then the second one was the emergence of standards to facilitate that growth. That's in place. Now, the last piece I talked about differentiation, and I hope that everyone agrees with me that in the SSD space today, what we see is what we call a SKUnomy. This is essentially a very large number of SKUs that are required to be delivered for an SSD manufacturer, or even system manufacturers to this day. Now, those SKUs can vary across a bunch of different vectors, and we've only listed a few here, but the form factor, which has sometimes something to do with capacity, the host interface, SAS, SATA, PCIe, and then the cost structure, of course. I mean, who isn't mindful of cost in today's day and age? All of these things drive the need for multiple SKUs of products in a given vendor's line card for the solutions that they deliver to the marketplace. So we take a step back and we say, well, we've got robust growth, we've got standards that have been developed, and we've got this deep desire to find some form of differentiation to address all of the different SKUs that are being created, and we need to be operationally efficient about it. And I sit back and I say, I think I've seen this somewhere before. So the vision that we wanted to describe was actually mapping to something that we're calling software-defined flash. And I'll be very clear to say that this is a vision. The concept behind this is very similar to software-defined storage, in that the idea is to take a base set of hardware and provide, via that hardware, interfaces and hooks that allow you to add differentiation on top of that base flash or memory subsystem. Now, in order to pull off something like this, where you have a vision, and if we follow the footsteps that tread before us, we need to have an ecosystem that comes behind that. And so what we decided to do is say, all right, well, let's take a step back and let's look at what exists today. There's essentially applications that get written, some of which have been around for a very long time, operating systems that are out there. There's a whole host of them now that are being used, some open source, some not. And then SSD solutions that plug into these, and standards across every single one of them. And this is actually, we think this model is going to last for a very, very long time. But we also think there's an incremental opportunity. That incremental opportunity using the SDF ecosystem that we articulate here, where if you take a step back and you look at what formulates the basis of that SSD solution, there's really three pieces. There's memory. So within an SSD or any memory-intensive subsystem, of course there's a desire to utilize different types. If you go back to the SKU-NAMI that we talked about, there's SLC-based solutions, MLC, TLC. And then if you go look at DRAM, which is used in a decent percentage of the drives too, there's a series of flavors of different DRAMs that can be utilized. And then memory vendors across all of them. So there needs to be some level of choice that can be applied to the memory. And then of course, there's controllers. You need to have something that formulates control of these different types of memories, the interaction into the host system, to perform essentially the housekeeping and the applications execution of these solutions. Now, what ties it all together, what's absolutely pivotal, and this goes back to putting the S in software-defined flash, is firmware. Firmware and software working together can be tailored in such a way that you can accelerate applications in a slightly more tuned fashion than you might otherwise if you had a solution that was developed for a certain corner of the market, a certain segment of the market. So I'm a silicon guy. You'll have to forgive me, at least at my core in the beginning. I'm a silicon guy. You have to forgive me, but I did want to take a quick look at the guts of what would a software-defined flash controller look like. And our vision for this is we actually see a couple of subsystems that need to exist in order to enable this model. One of them is processor cores, and developing multi-core solutions in this world is not a novel thing. It's not a new thing. It's been done by many others before. But that paired with a programmable flash interface that enables multiple types of flash to be developed, as I mentioned before, that also enables the exercise of call it proprietary command sets that have been developed to get the most out of the memory that hangs off of that NAND bus. That's something that we see that the market is definitely interested in. And then lastly, accelerators. Accelerators can be placed into these solutions, enabling certain functions to be developed. But we think these are some of the core building blocks that would enable a software-defined flash controller. And in fact, if I kind of go back to the couple of keynotes that we saw earlier today, in the case of Alibaba, they were talking about application-aware flash, enabling an infrastructure that takes into account how an application has a workload and being able to custom tailor a solution that helps accelerate that workload. And we think a model like SDF actually will permit that to be possible. And then also, Bob Brennan and Jim Elliott from Samsung were on stage, and they were talking about injecting some level of intelligence into storage. And we think that something along these lines is very similar too, using a software-defined flash controller to actually execute those applications to perform capabilities closer to the media itself. So this is the summary of the controller side of things. I thought it would be instructive just to give a very quick example. So if you have a moment and you can stop by our booth, we have a product family that we've introduced in the past called the FlashTech NVMe controllers. These are PCIe-based controllers, and we have a couple of flavors of them. One is a 16-channel interface to NAND that's optimized for 2.5-inch drives. And another is a 32-channel device that's optimized for card form factors. I mentioned that you've got these multiple SKUs to be developed. And then within our solution, what we offer is not just these devices, but we offer a reference firmware. And the number of customers that are utilized this, we have a handful of customers that we would break down into, I think you could categorize them. SSD customers who are building SSDs, customers who are building application-aware flash in their data centers, and then customers who are building all-flash arrays. Each one of these takes this reference code that we provide, and they decide what pieces they want to use, but then they custom tailor that firmware in such a way that it helps accelerate their particular application in the best way possible to give them the best performance possible. So this is one example. Now, I don't want to lead you to believe that it's just the controllers that play in this ecosystem. I mentioned that there's also memory, there's also firmware, there's applications, there's operating systems. I think there's a role for all of them. But I also want to point out that I think you can enable software-defined flash, not just at a controller level, but I think there's also implementations that exist at a higher level. It's something that would be more like an adapter card form factor that packages together a lot of what I talked about before, the firmware, the memory, and the controller. And it does so in such a way that you provide an API so that customers can come in and they can innovate on top of that. They can exercise that base element through software. And we actually just introduced today a solution that does this. You'll actually, if you have the opportunity to swing by, we'd love to talk to you and show you this in our booth. But this is our FlashTech NVRAM drives. We have a couple of different flavors of this, but essentially what this is a very high performance RAM drive that actually has the capability where if power faults occur, we can actually recover from that, leveraging SuperCap technology that we've developed out of our RAID cards. These solutions are actually being profiled in our booth, and we'd love to show them to you. The key thing is that we actually have enabled a way for applications to write on top of these and leverage that base infrastructure. So with that as a backdrop, I just want to conclude by saying that we think that there's a great opportunity leveraging learning from the past, from the PC industry into the software-defined storage world that we think directly applies to flash. We'd love to participate with several of you if you believe in the vision to go make this happen.